Hello learners, this is Venkat Narayan Knowledge standing before you. Today in this video I would like to present the topic that is something class 5 part B with the 2 exam problems and one Gaussian random variable. Okay, here example, just we will read out a discrete random variable as a distribution function fx of x is equal to 0.2 into u of x minus 1 plus 0.3 into u of x minus 2 plus 0.5 u of x minus 3. From this find density function. What is fx of x? Small fx of x is density function. Derivative of distribution function is density function. What is derivative of unit step function? Density function represented by del of x at the same point of occurrence. Therefore fx of x is equal to, here it follows at the same probability, 0.2 into del of x minus 1 plus 0.3 del of x minus 2 plus 0.5 del of x minus 3 with this power. Okay, next another example problem. Evaluate the integral. Evaluate the integral. Evaluate the integral. What is the integral here? Integral minus infinity to infinity 2x square plus 2x plus 1 into del of x minus 1 dx. Here we need to apply the integral property of the sampling function. What is the integral property? Since integral minus infinity to infinity pi of x del of x minus x naught dx is equal to pi of x naught. We have to apply the same notation for this equation. Then what will we get in? It follows is equal to 2x square plus 2x plus 1 at x is equal to 1. Substitute this value here, what we get? 2 into 1, because 1 square is 1 plus 2 into 1 plus 1. 2 to chap, okay, 2 1 are 2, 2 plus 2, 2 1 are 2 plus 1 is equal to 5. Okay, with this 2 exam problems based upon this previous video, it is closed. Now let us move on to the new concept of random, that is Gaussian random variable. The Gaussian random variable. Gaussian random variable. Application point of view, this is very important. Okay, the Gaussian random variable. Say for example, with this given Gaussian random variable, the density function is of the form. The density function of a Gaussian random variable. Of a Gaussian random variable is fx of x is equal to 1 divided by square root of 2 pi sigma x square e power minus of x minus ax whole square by 2 sigma x square. Once again I am repeating, fx of x is equal to 1 divided by square root of 2 pi sigma x square e power minus of x minus ax whole square by 2 sigma x square. What is this ax here? Ax is called mean. What is sigma x here? Sigma x is called standard deviation. Standard deviation. What is sigma x square? sigma x square is called variance. Okay, Ax is called mean and sigma x is called standard deviation. What is sigma x square? Variance. Okay, here what is the range of values of Ax here? The range of values of mean Ax lies between plus infinity and minus infinity, and sigma x is always greater than 0. It is a positive real quantity. That means here Ax and sigma x are real constants. Okay. What is the other name for this Gaussian distribution function? Other name is, it is also called as normal distribution function. The Gaussian distribution function is also called as normal distribution function. Okay. Here, what is the source here? Source. The source of this Gaussian random variable is the voltage across a resistor in an amplifier. What is here? Voltage across the resistor in amplifier is caused due to randomness in the current, which is because of thermal excitation of electron hole pairs. If temperature varies, electron hole pairs also varies. If electron hole pairs varies, current varies. If current varies, voltage varies. This type of distribution is called as Gaussian distribution. What is the application area? Application, I am writing in short form. Application area is science and engineering areas. Science and engineering areas. It is widely used in science and engineering areas. How do you get this distribution function? The distribution function is given by the distribution function is fx of x is equal to 1 divided by square root of 2 pi sigma x square integral minus infinity to x e power minus of zeta minus of ax whole square by 2 sigma x square d zeta. What is this distribution function? Distribution function is given by which property? Property number 3. Property number 3 of the density function as fx of x is equal to 1 divided by 2 pi sigma square integral minus infinity to x e power minus of zeta minus of ax whole square by 2 sigma square d zeta. Okay. This has no closed form solution. No closed form solution. Hence, we go with some assumptions here. What are the assumptions here? Mean value is 0 and variance is unity. Let ax is equal to 0 and sigma x is equal to unity. Then this distribution function fx of x, this distribution function fx of x will become normalized distribution function. Normalized distribution function. Then normalized distribution function which is indicated by f of x. What is f of x here? Normalized distribution function. Normalized distribution function. Okay, that is f of x is equal to under square 1 divided by 2 under square root of 2 pi integral minus infinity to x e power minus zeta square by 2 d zeta. This is called as normal distribution function. Okay, and here for negative values of x, negative values of x, f of minus x is equal to 1 minus f of x. Okay, for negative values of x here, f of minus x is equal to 1 minus of f of x. Okay, then what is the relation between a normal distribution function and normalized distribution function? It follows here. It follows fx of x is equal to f of x minus ax by sigma x. This is very, very important. I am highlighting this one. Okay, f of x is equal to fx of x is equal to f of x minus ax by sigma x. Okay, how is the plot is being drawn here for this Gaussian density function? Look over here, density function is given like this here. Okay, density function is like this. It is 0, it is x, it is fx of x. The maximum value occurs at ax, and it is at a spread of one is ax minus sigma x, the other one is ax plus sigma x. The value is 0.607 times the 1 by 2 pi sigma x square, and this value is 1 by 2 pi sigma x square. The maximum value occurs at its mean. By how much spread it is spreading around its mean is given by the sigma x, that is standard deviation, plus sigma x and minus sigma x. And here this is the density function. How to get this distribution function? Distribution function also obtained from this function like this here. 0 x, this is fx of x. Let's say for example it is extremities. One is x plus sigma x and the other one is ax minus sigma x. And here say for example it is 0.5, it is 1, and x is equal to ax plus ax minus sigma x, and the other one is ax plus sigma x. The other one is its center value x. The graph will be like this. Okay, the value at x is equal to ax plus sigma x is given by 0.841. The value of the distribution function at x is equal to ax minus sigma x is given by 0.159. Okay, this is the density function, this is the distribution function. Let us have a quick recapitulation. First one, the exam problem, basically given the distribution function, obtain the density function, derivative of distribution function gives the density function, derivative of unit step function gives the impulse function with the same point of occurrence. Next one is the problem based upon the integral property of sampling function. Next one is the Gaussian random variable. The Gaussian random variable has the density function like this here, shown in this equation, where ax is called mean and sigma x square is called variance, sigma x is called a standard deviation. And here, where the range of mean is between minus infinity and plus infinity, and sigma x is always greater than 0. And here it follows here. Here, next, where we get this distribution function source, where the voltage across the resistor in an amplifier, which is varying because of randomness in the thermal excitation of electron volt pairs. Okay, that is example source, and the other one is application area. It is widely used in science engineering areas. Very, very important, this point. And next one is, here it follows for negative values of x, f of minus x is equal to 1 minus f of x. 1 minus f of x. Discipline function, we get the normal relation between normalized discipline function and normal discipline function as fx, f of x, fx of x is equal to f of x minus ax by sigma x. Observe here, this is the density function graph, it is this discipline function graph. The maximum value occurs at its mean ax, and by how much amount it is spreading around its mean is given by sigma x. Hence it is at ax plus sigma x, the value is 0.841, and the value of at x is equal to ax minus sigma x is given by 0.159. With this, Gaussian random variable is finished. Okay. In the next class video, we shall have a simple example problem based upon the Gaussian random variable, and we shall enter into the new concept, that is other forms of distribution functions. Okay. If you like this video, please subscribe our channel and share it to your friends. Stay home, stay safe. Thank you.